In this video, I'm going to cover question 17 from the Math 26 Exam 1 review. The graph of y equals f of x is shown right here. Sketch on separate axes and give the transformation, shift, reflection, stretch, compression, and to what degree involved for each of the following. Give at least 2 coordinates for each graph. In this video, I'm going to focus on part A, part D, and part E. In a separate video, I will focus on part G. So let's focus on A for now. Y equals f of x plus 3. How do we graph that? This goes back to the notes that we had on chapter 1.5, which in the chapter 1 notes begins on page, it looks like 14. We had a summary of all graphing techniques. Whenever you are adding, it's going to be a vertical or horizontal shift. If you are adding inside the argument, it's going to be a horizontal shift. In other words, if you're adding inside those parentheses. If you're adding or subtracting outside the argument, it's going to be some sort of vertical shift. So you will get your graph and either shift it up, down, left, or right. If you're multiplying outside the function, it will be a vertical compression or stretch. If you are multiplying inside the function, it will be a horizontal compression or stretch. And finally, if you multiply by a negative outside the argument, it's going to be a reflection about the x-axis, and if you reflect about the y-axis, that's because you multiplied by -1 inside the argument. So going back to part A, we see right here we're adding 3 inside the argument. And so what that's going to do is it's going to be a horizontal shift to the left of 3, or another way you can think about it, the way I phrase it, it's going to be a horizontal shift of -3. And so what that does essentially is, one way you can think about it is moving the graph, but another way I like to think about it is going to the original graph and finding some key points. So for example, right here we have -2, -1. We have -1, 0. We have 0, 1. Then we have this high point right here of 1, 2. We have 3, 0 here. And so I'm going to take advantage of those points. What I'm going to do for each point, because I know I'm going to shift each point to the left by 3, is another way of doing that is thinking I'm going to subtract 3 from each x coordinate of that point. And what do I do with the y coordinate? Nothing. I leave the y coordinate alone. I'm only right now manipulating the x coordinate. So for example, that point of -2, -1 moves. Originally it was right down here, I should say. Now I'm going to move it 3 units to the right, to the left, I apologize, to the left. And so it becomes -5, -1. The next point, -1, 0, is now going to become -4, 0. I subtract 3 from the x coordinate. 0, 1 becomes -3, 1. 1, 2. 1 minus 3 is -2, so this is now -2, 2. And then that final point there, 3, 0. Once again, I subtract 3 from each x coordinate. I subtract 3 from each x coordinate, and that becomes 0, 0. Now again, I know the shape of this. It's going to keep the same shape as my original graph. I just move it to the left. And so you notice it's the same shape, but it's just shifted, literally just shifted to the left. Okay, we listed the type of shift. It was a horizontal shift of -3, or a horizontal shift of 3 to the left, you can put it. We also need to include at least 2 coordinate points here. And you can pick any essentially. I'll choose right now, let's say -2, 2. and 0, 0. But if you want to label the other points, that's totally fine. And that's it for A. Now, what about part D? Y equals 2 times f of x. Once again, if I'm multiplying, I know it's going to be a stretch or compression. And more specifically, if I'm multiplying outside of the argument, in other words, outside of these parentheses, then it's going to be a vertical stretch of this value right here. And so that's what I will do. Another way, again, of thinking about this, we are going to stretch the graph out. Another way of thinking about this is multiplying each y-coordinate from the original graph by 2. So if we go back to the original graph, I'm going to get, once again, I'm going to get each of these points, and I'm going to multiply the y-coordinate by 2. It's going to be a vertical stretch. And because I'm not doing anything horizontally, the x-coordinates are going to stay the same. So only the y-coordinates are transforming now. So negative 2 comma negative 1 becomes negative 2 comma negative 2. Negative 1 comma 0, I multiply the y-coordinate by 2, that stays negative 1, 0. 0 comma 1, 1 times 2 is 2 obviously, and so that becomes 0 comma 2. 1 comma 2 becomes 1 comma 4. And last but not least, 3 comma 0 becomes, well, when we multiply 0 by 2, it stays. And of course the x-coordinate we don't mess with here. So it stays 3 comma 0. And so you'll notice this is similar to your original graph. The only thing is it got stretched vertically. You notice the highs are higher, the low peaks are basically lower. It's just stretched away from the x-axis essentially. And that's it for D. Oh, we do have to label the points. So let's label at least 2 points. Let's go with negative 1 comma 0 and 1 comma 4. And we're done. All right, and that brings us to part E. Y equals f of 1/2 x. Once again, like I said, whenever you're multiplying, it's going to be a stretch or compression. And whenever you're multiplying inside the argument, inside those parentheses, it's going to be a horizontal stretch, per the notes. Now, horizontal stretches and compressions are a little bit tricky at first. You might think you're going to multiply each x-coordinate by a, but you're actually going to multiply each coordinate by its reciprocal, by 1 over a. So in our case, a equals 1/2. And so we're going to go back to our original graph. We're not going to multiply each x-coordinate by 1/2. We're going to multiply it by the reciprocal of 1/2. And the reciprocal of 1/2, 1 divided by 1 divided by 1/2 equals 2. So in other words, we're going to stretch it by a factor of 2 horizontally. Or of course, whenever we do something horizontal that's going to affect the x-coordinates, we're going to multiply each x-coordinate by 2 from the original graph. And again, the same thing. You're going to see negative 2 comma 1 is going to become negative 4 comma 1. Negative 1 comma 0 is going to become negative 2 comma 0, and so on. Just get those points, manipulate their x-coordinate, leave the y-coordinates alone. And so that becomes, like I said, negative 4 comma negative 1, negative 2 comma 0, 0 comma 1 stays that way. And you notice my graph probably wasn't the best in terms of its spacing, but that's okay. 1 comma 2 becomes 2 comma 2, and 3 comma 0 becomes 6 comma 0. And so more or less it looks something like this. And so you notice it's similar to your original graph, except that each point, or basically it's been stretched out away from the y-axis. It's been horizontally stretched out. Last thing we can do, of course, is label a couple of our points. So it asks for at least 2 points. We can of course go for 2 comma 2 is here, and let's go with 0 comma 1 right here. All right, and that's it for part A, D, and E. For the other parts, please check out the notes here to remember how these compressions and stretches work. And of course, I will work on, like I said, part G in a separate video. Thank you.